طيب بسم الله الرحمن الرحيم. Um, Today, inshallah, we're going to start chapter 1. And chapter 1 is a motivational chapter. It talks about the importance of networking on the way of life, on how the networks affect our daily lives. And we'll talk about some fundamental concepts related to the networks and the physical devices inside the networks. So globally, of course, networks have affected our way of life, and they exist in different forms based on how much geographical area this network can cover. They affect the composition of the network in terms of physical devices and software or logical services. So, as I said, since the early 80s, where the internet started to come about to facilitate the connection between two fixed computers, or to allow two fixed computers to just use or share some resources like a printer or something like this. So the original objective of the internet was just to connect fixed devices and allow two fixed devices to kind of communicate or share resources. This concept has transitioned very rapidly to facilitate the mobility, where now we have mobile devices that allows us to interface or to communicate between two different people. So people can use these mobile devices to communicate together across the internet. This has transitioned also to the concept of Internet of Things, where now we're not talking about devices, we're talking about things, where we have microchips embedded inside our clothing, or some of these chips are embedded even inside our bodies to measure certain characteristics or some physical conditions of our body, and use that for medical purposes, or to interface with the environment and take some measurements and use these measurements to enhance the lives of people and so on. So from one transition to another, from one era to another, throughout the internet evolution, the number of these devices has exponentially increased, and it almost doubles every year. So now we're talking about 50 billion things or devices in different forms that are embedded not just in fixed devices, but also in our bodies, in our clothing, in the environment. And in terms of number, this huge 50 billion things are orders of magnitude or of the population on Earth. So you can imagine the number of devices that are utilized and consumed per person on this Earth. So that gives you an indication that networks has really affected all our aspects of life. So networks, in that regard, they facilitate people to communicate in different locations. So as you can see, these people, they do not physically exist in the same location like these people. So they can use the network to meet virtually, irrespective, regardless of their location on Earth. And they allow, or the networking technologies, they allow these people to interact and communicate as if they are physically in the same location. Of course, that requires very sophisticated services and physical devices that we will talk during this course. So with that said, networks have really affected everything in our life. Every single aspect of our life has been affected one way or another by networking technologies. Networks have affected the way that we learn. And of course, one example is what we are doing now. So we are doing some distant learning using some networking technologies. So uh, all the online education and all of this have become available and feasible because of networking technologies. It affected definitely the way that we communicate together using different types of devices, whether it's laptops, mobile, things like that. It affects the way that we work and even the way that we play. Even games now have been revolutionized using the networking technologies. So now I can play games with some people in China or in the US, and we can play the same game as if that we are, in the same physical location. So that's a revolutionary concept affected our lives. Also, the the revolution or the proliferation of networks in our lives have been facilitated by the fact that networks can come in different sizes. They are very, very scalable and flexible. So they can cover a small office or they can cover a bigger, business company. They can cover a building. They can cover multiple buildings or a city or the entire globe. So networks, they can come in different sizes based on the geographical area that they can be covered by these networking technologies. And we'll talk about this later. Okay, so in terms of services and applications, the networks can come in two different architectures, two types of architectures. Okay, that's with regards to services and applications. So very high level. So in a high level, networks are divided in two different architectures. Okay, so the first architecture, we call it client server architecture. So in client server architecture, okay, there is always a designated device or a designated end device or an application that we call it a client, and there is always another bigger uh, end application that we call it a server. Okay, so the client is the entity that always, in all times requests a service from the server. Okay, so the client, the definition of a client is a designated end application that initiates the service or requests the service from the server, and the server is always the end application that provides this service to the client. Okay, an example is, of course, the email server at QU. So we all connect, we all have Outlook or any email application that we use to connect to the QU email server to fetch our emails. Okay, so this is an example of client and server. Also, when we connect to Blackboard, so we use web server at QU to provide Blackboard service, okay, using client server architecture. So in other words, client server talks about logical one-to-many relationships. So these are clients, client 1, client 2, client 3, client 4, and all these clients, they connect to one server, and they all take or request service from this server. Okay, so that's how the client server architecture actually works. I have to highlight here that just the fact that the client requests the service from the server, it doesn't mean that the communication is always going in this direction. Okay, because For example, for email, we can send email or we can receive emails, right? So when we send emails, we actually request the email server to send this email on our behalf. So in that case, we send an email to the server. Okay. When we fetch our emails, what we do is that also we send a request to the server to fetch our emails back to the client. Okay. But the request is always coming from the client. The request is always coming from the client. It never happens that a server requests things from the client. In other words, also that implies that the clients, they can never communicate to each other. This is also important. The clients, they can never communicate with each other. They always communicate with the server only. There is no communication ad hoc that happens between the clients. Type. What is the advantage of this? The advantage of this is that it's very easy to control. If you have one server that exists in a specific location, it's very easy to control. I can put some access restrictions for all these clients. Okay. For example, I put some access restrictions on certain files that they cannot be viewed by certain clients. I can do that because everything exists in one location. So, for example, Muhammad cannot see emails for Amr. Something like that. I can do this easily because it's one server and it contains everything. Okay, so all the content and all the control, okay, exists in one server, and the clients, they request the service from that server. Okay, so that's the advantage. The advantage is that it's easy to control and administer. Okay, I can put some access restrictions, I can put everything. So in terms of advantages, on one hand, easy for administration. Okay, and of course it's secure. Why? Because I can easily control the security policies on this server because it's one location. Okay, type. What is better the disadvantages? On one hand, it's complex in terms of the fact that these servers have to be huge. They have to have huge amount of resources, storage. They have to have processing power very, very high in order to cope with the requests of all these clients. Okay. Number two, it's a single point of failure. Of course, if the email server of QU is down, can anyone compose any email service? Of course not. I cannot send emails. I cannot fetch my emails. I cannot do anything with emails. If Blackboard is down, and it happened before, we are all doomed. We cannot access any course content. We cannot do anything on this Blackboard server. So it's single point of failure. So the client server architecture has some advantages and disadvantages. So the other extreme of this is not to designate a certain machine as a server. We call peer-to-peer architecture. For peer-to-peer architecture, we are all peers. Okay, peers means that we are all like each other. So if we talk about peers, so we have machines like this, but we are all similar to each other, which means anyone can talk to anyone. Anyone can talk to anyone. Logically, everyone can talk to everyone. Okay, which means that we have like a many-to-many relationship. So here, the peers, they can talk to each other, which means essentially that each peer acts technically as a client and a server at the same time. They can request service or they can provide service at the same time, okay, concurrently. So so if we talk about this as an example مثلا for hosting files on a peer-to-peer architecture. So for client server architecture, if we want to use it for hosting files, what we do is that we put all the files, everything. So we have a server here somewhere that maintains all the files in a centralized database. Okay, it controls everything, and the clients, they can talk to this server to get these files. Okay, this is client server. But for peer-to-peer, we will do it differently. What we will do is that we will host small content on each file. Okay, so instead of hosting the files in one centralized database, we will host the files distributed amongst all the peers. Okay, so in that case, we do not have single point of failure. Okay, so if one peer goes down, I don't have single point of failure because all the other peers are still up and running. They can provide service to other peers. Okay, so the peer-to-peer architecture has certain advantages and disadvantages, similar to the client-server architecture. So it's easy to set up in the sense that once you have the peer software. اتفضل يا يوسف. السلام ورحمة الله وبركاته. اتفضل. مهم. 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 أها. مهم. مهم. That's a very good question. Thank you, Yusuf. This is a very good question. Uh, no, it doesn't happen transparently. That, of course, if مثلا if this peer hosts a small content, okay, and this peer hosts small content, okay, and this peer hosts small content. If this peer goes down, the content doesn't get transferred automatically to the other peer, but these two peers can still communicate using the contents that they have. So they can still request and consume services from each other based on the contents that they host. Okay. So if this peer goes down, this part of the content will also vanish from the network. But this is a small part. It's not like client server architecture where if the host goes down, all the content goes down and we are all dead. We cannot consume that service whatsoever. واضح كده؟ But in peer to peer, if one peer goes down, we can still communicate. صح كده؟ So اتفضل. This information could be recoverable if you maintain the same content on two peers, and that sometimes happens. So, for example, there is some overlap between the content here and the content here. Okay, so if one peer goes down, you still have some of these content on the other peers, but this has to happen through the peer-to-peer protocol. The peer-to-peer protocol needs to take care of the fact that some parts of the content should be actually hosted on two different or three different peers or four different peers. تفضل محمد. Yes, تفضل. Right. Accounts. Mhm. No, 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 no. The content is distributed amongst the peers. This is the general rule, yes. But but in in real life, by the way, in real life, it's much more complicated than what we're talking about here. It's neither client server nor peer to peer. So in real life, the architectures that we have in real life, it's actually a mix of both, and I'm going to talk about that. So in other words, you can use peer to peer, but you can replicate the content, parts of the content, parts, only parts of the content on different peers. Okay. You can use also client server, but you can have multiple servers that they seamlessly work as a server, and even the client doesn't know which server it connects to. That also happens. Okay, I'm gonna give some more information about this as we go. Okay, so the peer-to-peer is easier to use because it's once you set up the peer, off you go. So you don't have to really do lots of administration and do some access rights and restrictions on the files and so on and so forth. It's very simple. You just download a peer software. For example, BitTorrent. BitTorrent is an example of a peer-to-peer network, by the way. But again, it's not a pure peer-to-peer. I'm going to talk about that. So BitTorrent, Gonatella, or there are many of these peer-to-peer software. Once you download BitTorrent on your machine, you just start it and that's it. You don't have to really worry about setting up user rights, access privileges, and so on and so forth. It's less complex, of course, because you don't have to provide this service to everyone in the network. You can provide the service to some other peers, but not necessarily all peers. So in which case, you don't have to have very, very huge amount of resources in terms of storage and so on, because each peer is hosting only part of the content, not the entire content, right? So number three, it's less cost, of course, because again, it's not, you don't have to have a designated server with huge amount of resources. So it's definitely low cost. It's used definitely to provide simple tasks, because again, you can provide the service to a subset of other peers. You don't have to really provide this service to many other peers. Um, but on the other side, if we're talking about peer-to-peer, the administration is not centralized. Okay, so no single entity on the network has control to the contents, right? So I don't have any control who accesses which part of the content at any point of time. Any peer can access any content, okay, at any point of time with no control. I don't have any control. So why is this a disadvantage? If you don't have control, then you can have anyone accessing any part of the content at any point of time, and this content might be a virus. This access of this content might be illegitimate, and that's why peer-to-peer networks, by the way, are very much used to spread viruses in many ways and to provide some illegal services in general. And at least part of these services might be illegal, and they provide some ways to spread viruses and so on, because you do not have specific control which is administered by a single entity. Okay, and of course that leads to number two, which is not secure. Of course, if you do not have centralized control of this content, some of these contents might be embedded actually on purpose to spread viruses amongst all the peers. And that's why BitTorrent, for those of you who have used BitTorrent before, if you download anything using BitTorrent, probability is more than 50% that it contains some kind of virus or Trojan or something like this. Because again, this content is not controlled by an entity that's legitimate. You don't know where this file is coming from. It might be coming from a machine in China, India, anywhere, and you don't have any control how this access is actually legal, is legitimate, and so on. Okay, type. It's not scalable. Why is this? Because I can illustrate this using another figure. So if you have multiple peers, for example, this is peer zero, and this is peer one, peer two, peer three, peer n. Okay, so if you have n different peers, peer zero wants to fetch specific content. Let's say a file called مثلا عمرو.txt مثلا or anything like that. Okay, because of the fact that the content are distributed amongst all the peers, peer zero doesn't know where this file is, right? So originally I don't know where this file is. If it's client and server, by default I know where this file is because there is only one server. I go to that server to fetch the file content for amr.txt. However, in peer-to-peer, I don't know. So I have to basically go to peer one first, ask peer one, do you have amr.txt? He would say no. So I'll go to peer two, peer three, peer four, and so on until peer 10. Imagine بقى is n is 1 million devices. So I have to go through sequential search to try to find the content for amro.txt, and I will spend forever to try because all these peers are distributed across the internet. Some of these peers might be in China and India and US, here and there, so I don't know where this file is. So I have to ask everyone. And of course, this will take huge amount of time. And that's why I'm saying that in real life, we do not have pure peer-to-peer architectures. Even BitTorrent is not a pure peer-to-peer service. They use peer-to-peer, but with centralized administration. So there is BitTorrent server, okay? That it does not, the server does not host the content, okay? But it's used for centralized administration. So that's why when you say no centralized administration here, we mean the pure peer-to-peer architecture, because in real life architectures, you have to have some way of centralized management and administration. But the pure peer-to-peer architecture does not have any centralized administration. So therefore, it's not scalable because you have to do sequential search for any content because you don't know where this content is hosted, and that takes a huge amount of time. Okay, so all devices act as both clients and servers, which can slow down their performance. Of course, as you can imagine, if I work as a client and I consume the service from the server, it's easy because I request the service and that's it. But imagine that if I work as a client and a server at the same time. So I have to host some content on, so imagine if I have مثلا a cell phone, and this cell phone acts as a peer. I downloaded مثلا BitTorrent, and this phone acts as a peer. Even if I'm not consuming any service, others might consume service from my machine, which will drain the battery, which will consume the CPU time, which will do this and that. And sometimes I don't even feel it. And I find if I download like some peer software on my cell phone, and I close the cell phone, I don't actually consume anything. I don't use anything, but you find that the battery is draining and the CPU time is used. Why? Because just the fact that you are not consuming any service doesn't mean that others are not consuming service from your device. This is the disadvantage of peer-to-peer architecture, because the peer works by default as client and a server at the same time. Okay, any questions related to this, Shabab? So as I said, in our real life, we don't use neither. We use somewhere in between. So even with client servers, if we want to avoid the fact that client server architecture is single point of failure, we actually replicate the servers. Okay, so that's why, you know, we never مثلا get any service down on WhatsApp or مثلا Google or something like this, almost never. Why? Because they use, or YouTube مثلا, imagine YouTube مثلا, you consume heavy, very heavy service, and almost never we find it down. Why? Because they replicate the servers in different locations and in different forms, so that you can consume the service not from a single server in that case, but you can consume it from multiple servers. And if one is down, you go to the next and you don't even feel it. You don't know which server you're connected to. And on the other side, for peer-to-peer, as I said, but we don't use pure peer-to-peer. We have to use some form of centralized administration and control that allows us to have better control and more efficient control on the content. Okay, so that's this is the difference between client server and peer-to-peer. Type. In terms of the components of a network, of course, the network is composed of some physical components and some non-physical, or تفضل. مهم. مهم. لا، هو احنا هنا بنتكلم from the perspective of services and application. It could be local area network, wide area network, could be anything. These are applications يعني above. يعني that's why I said that the peer software might be running on a device in China, or might be running on a device in Qatar or US. Doesn't. Yes, it's a concept or high level architecture for services and applications. Okay, now we will go down. Now we will go one step down and talk about the physical components of the network. Okay, and it will become clearer as we go. طبعا احنا we are still in the introduction, so we're trying to, you know, motivate you why this topic in this course is really important, and how it affects our way of life, and how, what is the perspective and the context that exists in these networking technologies that allow networks to affect our way of life. Okay, so in terms of components of a network, we have some physical components. Okay, so these are physical components. These are physical. And these physical components are either devices or media. By devices here, I mean all these highlighted devices. These are physical devices. Okay? And we will divide these physical devices in a minute. All these are physical devices. We see them. You will see them in the lab. All of these types of devices, you will see them in the lab. You will be able to configure them. Okay, and act and interact with these devices physically. Okay, also media, by media we mean connections that connects these devices together. Even wireless is a type of medium, although for wireless we use the air as the medium, but we consider it a physical medium because it facilitates the transfer of, or the transmission of, signals in the air until it reaches another device. So in that case, it's a physical medium. So wireless is a physical medium. Okay. طيب, services بقى, services are not something physical. Services refer to the software, okay, or to the logical applications that run on these devices in order to allow these devices to communicate together. As we have learned in earlier courses, computers are hardware and software. Software are some services and applications that run on top of these devices to allow us to communicate through these devices. طيب, so in terms of devices are divided into two types of devices. There is the end devices, and by end devices, I mean the devices that the actual user, okay, uses these devices to interface with the network. These are end devices. An example is, of course, my cell phone. My cell phone is an end device because I use it to consume services and to interact with the with the network. Any computer, any type of computer, like workstation, laptop, file servers, any kind, either client or a server, doesn't matter. All these are devices that we use to interact with the network. Okay, voice over IP phones, and we'll see the symbols of these. Any kind of security cameras, any kind of device that we use to consume or to communicate over the network. Okay, so these are end devices. The other type of devices is what we call infrastructure or network devices. So these devices are not to be used by us as users. These are used by the network administrators. Okay, so in other words, we as users, okay, we use the end devices to interact with the network. But inside this network, there are some routers and there are some switches. We don't see them. We don't interact directly with them, but they are used to facilitate the communication between the end devices. Okay, so these are network or infrastructure devices that are used to facilitate the communication, and they are not to be used to interface the users to the network. Okay, so users do not use these network devices directly. ماشي كده. Examples of these are network access devices like switches, routers, wireless access points. So for example, if I use Wi-Fi on my cell phone, implicitly I'm using some kind of an access point, okay, infrastructure device, access point to use Wi-Fi. If I'm using, like for example, Ethernet, or if I connect a cable to my laptop and connect it to the network of QU, then I'm using, I have to use in the middle some kind of switches or routers to facilitate the communication all the way to the internet. I don't see them as a user. As a user, I don't see the switches and routers, but they are there, and they are hosted in the ITS department to again facilitate the communication to the internet. Okay. Firewall devices are also some type of devices that are used for security purposes. ماشي كده يا شباب. Any question to interrupt me? So one, we talked about devices, and devices we divided them into end devices and infrastructure or network devices, right? Number two, we talk about media. Media are the connection form that connects two devices together. Okay, we have three types of media. We will talk about them in much more details in chapter 4, inshallah. Very quickly, we have the copper cable or the copper medium, and copper اللي هو النحاس يعني. Copper medium can be used to connect two devices together. Okay, and you have two forms of these. You have coaxial and UTP. We'll talk about these in very much details in chapter 4. Number two, fiber optic. In fiber optics, it's not made of copper in that case, it's made of glass. Okay. Or number three is wireless. So in wireless, we don't have copper media or glass media. We have air. We have the air acts as the medium in that case. What distinguishes each of these types from each other, that in copper are normally used using electric signals. Okay, so copper use electric signals. Fiber optics use optical signal, of course. For fiber optics, we use light. Okay? And wireless, we use what we call microwave signals or electromagnetic signals. So the electromagnetic signals, they travel through the air and they get physically to the other device, and that's how we communicate. Okay? So these are the three types of media with the three types of signals that each one of them use. And again, we will talk about them in greater details in type. In terms of representation, you will see these symbols a lot throughout the course. You will see them a lot. So for example, if you see a symbol like this means that this is a single workstation. This is a symbol of a laptop. This is a symbol of a printer. This is a symbol of a monitor, and so on. This is a wireless tablet, and this is an iPhone or IP phone. So these are for end devices. Symbols like these represent routers. Symbol like this represents a switch, and so on. This is wireless router because it has antennas. This is a wired router, and so on. For media, for media types, we can we can use this representation for the media. So, for example, this represents electromagnetic or microwave signal that travels through the air to indicate that this is wireless. And for LANs, we normally use straight line like this to indicate that this is a copper. Device that one second. This is a copper device that uses electric signal to communicate, and so on. Okay. So when we interconnect these devices with cables, okay, we form what we call a topology. A topology is a formation of devices that are connected together using cables. So if we connect cables with devices in a specific form like this, okay, then we call it a physical topology. For physical topology, we can see everything. We can see hubs, we can see switches, we can see routers, and how physically all these components are connected together. However, when we talk about logical topology, sometimes network analysts, they use logical topology as a simplified form of looking at the network. So in logical topology, we don't see switches and routers, خالص. We don't see the switches and hubs. Okay, we don't see switches and hubs at all. They are simplified or represented in a logical way to show how these devices communicate over the network. And again, the difference between physical topology and logical topology, we will discuss it again in more details in chapter 4. So we'll talk about the properties or the different properties for physical topology and logical topology in a lot more details. Okay. So very quickly, so there was a question about LANs. So a LAN is a logical area network, which is used to cover a small geographical area. And wide area network, from the name, it's used to cover a wide geographical area. Forget about these types. These types are somewhere in between that we will not use in the course that often, but we need to distinguish LANs from WANs. So LAN covers small geographical area, usually مثلا a lab or a class, a small class, a small physical class مثلا in a university, or maximum like one floor in a building. Okay. So how we distinguish a LAN from a WAN? So for us throughout the course, we will definitely talk a lot about LANs and WANs. So if you don't see this symbol represents a router. If you don't see this symbol in the middle here, okay, instead you see مثلا a switch or a hub, then this is one LAN. Okay, this is the general rule. So if you don't see routers in the middle, this is one LAN or local area network, which is used to cover very small geographical area. ماشي كده؟ So in other words, if you see a router like this, so this means that whatever is connected to a router port here is one LAN. So this is LAN 1, okay? And here, because this network is connected to one router port, so this is LAN 2, okay? And here, this link here is LAN 3. And if you connect all of them together, this is one WAN or a wide area network. So in other words, a WAN is an interconnection of multiple LANs. Each LAN covers a small geographical area. That's it. ماشي كده؟ Any part. So the ultimate WAN is the internet. So the WAN that interconnects all the LANs that covers the entire globe is what we call the internet. So in other words, this is a LAN, this is LAN 0, LAN 1, LAN 2, LAN 3. Each of these LANs, as you can see, it's terminated by a router port. It's terminated by a router port, but there is no router inside this LAN. So this means that this is one LAN and it covers a small geographical area. ماشي كده يا شباب؟ So if you connect all these LANs together, it's a WAN, and the WAN is recursive. It gets bigger, 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 and bigger until it covers the entire globe, and this is what we call the internet. ماشي كده؟ So that's all what we need to talk about today. Inshallah, next time we'll talk about other basic concepts as part of this introduction before we get into the different layers of the network function and why we divide the network function into different sub-functions and so on, which we call them layer and protocols, and we'll start talking about that. أيوة أحمد تفضل. Yes, if you have two routers, معناها you have two LANs, of course. معناها you have two networks. Yeah, that's how it works. I used to have two routers in my house, and each router is a separate Wi-Fi actually. So I can connect to one router or the other, which means I have two different networks. But you can use it so that logically you have one big network, but physically you have multiple LANs. Of course, physically you have multiple LANs. Okay, but there is a way that you can configure your network at home to be used as one logical network, but physically they are multiple LANs for sure. ماشي كده؟ So again, a LAN is terminated by a router port. Once you see a router port, this is the end or the termination of a LAN. على طول. That's a common rule. ماشي كده يا شباب؟ Any other questions? Okay, إن شاء الله اتفضل. I didn't. I think I already did, but I will double check. If it's not there, I will upload it right away, inshallah. I thought I did, but then I will double check, inshallah. I will make sure they are there. But in any case, this lecture will be recorded and will be posted on YouTube. And after 1 or 2 hours, you should see it on YouTube, and you can watch it later, inshallah. Any other questions, ya shabab? Of course, there's no attendance, of course, until the add drop period is finished. Any other questions? Okay, so we'll see inshallah next time.